Welcome to the third tutorial of this micro games series. This time around, we will be building from scratch a first-person shooter. Once you're ready to get started, head over to nrgcore.com and under Learning, Demo Projects, NRG Sandbox, grab a copy of the NRG Sandbox by clicking on the upper right corner link. Next, repeat the operation for Learning, Microgames, and MicroBots, once again located on the upper right corner. Click the link to download the microbots.zip file that contain all the assets that will be needed for this particular tutorial. Next, decompress them at a convenient location and head over to the Energy Editor. Open up a file explorer based on the platform that you are. I am obviously on Linux right now. If you're on Windows, open File Explorer. If you're on Mac, open Finder and head over to the directory where you decompress those two files. In this case, they are on my desktop. And I'm going to open up the NRG Sandbox directory and create a copy of the NRG Sandbox.npk. So I'm going to copy that and I'm going to place it on my desktop. Once this is done, I'm going to go to inside the NRG editor and open project on my desktop, NRG Sandbox.npk. Open that up. And the editor is asking me if I want to unpack the active project. I'm going to confirm the operation. So like that, I can have read and write access on the project. By doing this operation, a directory, also an NRG Sandbox directory, have been created on my desktop. Later on, I can rename it to be NRG MicroBots or any other name. But for now, we're going to stick to the default one and start assembling our first-person shooter. So the first thing I want to do, I am going to create a new directory for my MicroBots game. So I'm going to double click on my NRG Sandbox root and I'm going to call it MicroBots here. And I am going to head over to the NRG Sandbox directory, click on the Sandbox scene and hit the duplicate button to create a copy. And I'm going to call it as well MicroBots. And I'm simply going to drag and drop it under the MicroBots directory. Now I'm going to, I want to load this scene for editing. So the first thing I'm going to do, I'm going to disable under properties application. I am going to disable the controller script for the sandbox scene here. And next I'm going to head over to scene properties and simply click the clear button to unload it. Now under my MicroBots directory, I'm simply going to drag and drop my MicroBots scene. So basically it is now loaded and I have a full copy of my NRG Sandbox scene. I'm going to start tweaking things up. So I'm going to head over to the outliner and basically I want to keep everything that is necessary for the renderer, all the geometry, the cameras that are here and the probes. And I want to keep also the skybox and the sun. What I don't want is all these walls and the floor and everything. That should start about here at cube 004. So I'm going to select that and ensure that it is selected and drag all the way down to select everything in one shot. And I'm going to hit the delete button to clear that out. I am also going to want to modify the environment. And before doing that, I'm going to click on my skybox object and go under properties and constraint, because in the sandbox template, this sky dome is actually following the camera and I don't want that for my current game. So I'm going to go under constraint and disable these two transform constraint. Next, I'm going to head over to the object properties and I'm going to stop the skybox from rotating. Under script, I'm going to disable the rotate skybox script. And since I'm there, I'm going to zero out the location of that skybox. All right. And now basically what I want is to replace this environment. I am going to reuse the same environment that have been created when we were doing the microlands, micro games. So if you want to check that out. So what I'm going to do, I'm going to show you another technique. That previous tutorial, I was passing by selecting the library here by assets and import and start importing all the faces, then creating the cube map. I'm simply going to show you another technique that allows you to bring in existing NRG asset into a new project. For that, I'm going to pop another file explorer right here, head over to my desktop. And as you can see now, I got my NRG Sandbox directory that have been created when I extract my NPK. And I'm going to head over to the MicroBots directory here that you have received. And I'm going to right click and copy the environment folder and I'm going to go back under my desktop and NRG Sandbox, my MicroBots directory right here. And I am going to paste that. So I got if I have a quick look at it, I got 2 cube map along with the phase that goes with it for irradiance and radiance. And now I'm going to reload my project and resync the current asset library. So to make sure that the environment is now part of my MicroBots directory. So in the NRG editor, I'm going to go under File and Save. And with the library selected, I am going to click on this little icon here that is going to reload my project and sync the asset. And as a result, now I have the environment directory that is up here. And if I browse them, I can see that I have my cube map and all the faces that goes along with the 2 associated cube map here. And I am now going to want to replace the cube map of the material that is used by the skybox. So I'm going to go under Properties and Material, open that up and go fetch my skybox material. And under Sampler, you can see that here it is connected to the sandbox environment. I want it to be connected to the MicroBots environment. So I'm going to select the slot and I'm simply going to go search my radiance cube map that I'm going to drag and drop here and done. Now I got my new environments that have been connected. Next, we're going to leave the visual tweaks for later. Leave that for now. We're going to do everything in one shot. Now our priority is to import our first level for our game. We are now going to head over to Blender and load the microbots.blend file that is located under the MicroBots directory that you have extracted earlier. What we're going to export is basically our first level as well as our default robot and the collectibles that will be part of our level. So in Scene Collection, ensure that the bot is actually visible and sector 1 is actually visible, as well as our collectibles, which are basically the gun, health crate, and ammo crate. So with that said, we are going to export everything in one shot this time compared to the other micro games that we were having a library. And if you notice, each and every material that are present in this scene are labeled bots underscore something. So we're going to need to create a render layer preset for that. So with that said, I'm going to push A to select everything and I'm going to go under File, Export and Collada. And I'm going to place that inside the MicroBots directory. Under the main tab, I'm going to ensure that selection only is on, and on the geometry tab, triangulate and apply viewport modifier. Export that. I got my objects exported. And now, unfortunately, the Collada format does not export the metallic and roughness value, and I am going to need that since I am using in my NRG Sandbox a PBR renderer. So what I'm going to do, with all that selected, I'm going to go under File, Export, and GLTF, and I'm going to ensure that the format is GLTF embedded here. So basically, the GLTF embedded is a JSON file, and we're going to use a JSON Lua parser to be able to extract our metallic and roughness information. Under Include, I want to make sure that selected object only is on, and I'm going to export my GLTF file. Now I'm going to go back inside my NRG editor, and under the library with my MicroBots directory selected, I'm going to go under Asset and Import. And before I'm doing this, since we are going to be actually deriving the plain material that is already present inside the sandbox, let's load it in on the side so we can have a template to take reference to. So I'm going to type plain here on the material, plain, and this is basically the kind of material setup that we're going to need to reproduce in our render layer preset. So I am going to go back in library, and this time I'm going to go on Asset, Import, and select my Collada file DAE. Open that up. Under Geometry, leave that intact. Under Materials, I am going to go under Material Presets, and I'm going to create a new preset. So I'm going to click the little gear here, new preset that I'm going to call Bots, and the identifier that needs to be present in the material name to trigger that specific preset will be bots underscore something. So for the shader, we're going to use the lib material plane shader. So I'm going to click here and type plane to bring it up. And under script, the script that is connected to the plane material is going to be the set uniform that is going to basically send over to my shader the sun color, the sun direction. as well as the matrix, the projector matrix of all my probes for later on rendering cascaded shadow map. So I'm going to connect that as well, set uniform. And if we check sampler 0, 1, and 2, on sampler 0, I got a cube map, 2, I got a cube map, and 3, I got my shadow map. I am going to hold shift to switch the type of asset that I will be selecting. So 1, 2 for a cube map. On sampler 1, 1, 2 for another cube map. And the last one here, 1 to have a texture. So this time, at the moment, the lib material plane is connected to the sandbox environment. I want it to be connected to the MicroBots environment. So in sampler 0, I am going to go select my MicroBots irradiance environment here. In sampler 1, my MicroBots radiance cube map. And sampler 2, I am simply going to pick my shadow map here. Okay. Now, since all the objects that we have selected in Blender and exported, we want them to actually cast and receive shadow at the same time, we are going to scroll down and head over to material preset. So we're going to create a new material preset for every new object that are going to be placed on the right depth render layer, which is the render layer that is grabbing the depth information that will later on be translated into shadow. We want all the object that will be placed on right depth for all the primitive, leaving this field empty means all primitive of the geometry for the current object. We want the right depth material to be applied. So for each new object on the render layer, right depth, all primitive, apply by default to all of them, the right depth material. Under animation, I'm going to turn that off. I don't want animation right now. Skeletons, I do have a skeleton that is attached to my bot, so I'm going to import that as well. And under visual scene, I am going to ensure that right depth is on for casting and receiving shadow, and geometry also is on, so all my new object will also be shaded. So I am going to import that. It's going to take a second. We have like 300 and something objects to import here. And once this is ready, we can see that we have basically the integrity of our scene, and we can see our bot here along with the gun and the crate. But obviously the coloring shading is not right. That is because the Kaleda file does not contain that information. So I'm going to remedy to that situation right away. I'm going to go under properties and then application. And I am going to go under external files to bring in a JSON parser. I'm going to select that the platform is application, and I'm going to go under external file and click the icon to bring the JSON.lua file that is going to help me to parse that GLTF file that I just exported. I am going to open that up. Next step, I'm going to go under my library in MicroBots, and I have a little utility that allow me to load a GLTF file and parse it and restore that metallic and roughness information. So I'm going to go on asset, and this time around, I'm going to go and click on append existing asset. And under my MicroBots directory, I have that little utility for the occasion. I'm going to open that up and jump straight away to the coding layout. Under MicroBots, if I expand utility, I have this utility, this graphical user interface that is allowing me to import a GLTF file and parse the material value. So I'm going to click select to select a GLTF file. I am going to go pick my microbots.gltf that I've exported earlier, open that up. It's going to take a second to parse and process. And now we have all our coloring, our color, metallic, and roughness information that are basically into our scene. At this point, we are now ready to start working on the robot. And from there, we are going to move on with more scripting and logic controls. We are now going to import the action for our robot. To do that, we are going to jump back in Blender, and we are going to hide the bot scene collection, sector 1, collectibles, and we are going to focus our attention on the bot action here that I'm going to make visible. And you can see that we got a bunch of armature here with the idle animation to walk forward, backward, left, right, and we also have a death animation. It is very important. We're going to start with idle. It is very important when you're exporting an action that you actually export the good amount of frame for each and every action. Like an example, in this case, the first frame for that specific action, the idle, start at 1 and end up at 64. So in output properties, we're going to set the same range here. So 1 and the end frame is 64. That is going to ensure that we got the good range for each and every action that we are going to export, because you don't want to end up with too many frames or not enough frame. So I'm going to export my idle animation first. So file, export, and Kaleda, MicroBots, and I'm going to ensure that selection only is on. Export. Back into my NRG editor, I am going to enter edit mode just to make things clear. Shift in 2, second render layer, and I'm going to select here my robot. We are going to append the action that we have been exported, to our object that it's named bot. So I am going to go under MicroBots and asset import, and I'm going to go fetch my microbots.dae, open that up. I do not want to import any geometries and materials as well. We're going to focus on animation in a second. Skeleton, no skeleton, I already have it. And in visual scene, we are going to turn everything off. So under animation, I want to import the animation library, yes. And I want to append the action, the animations that it contained in the Kaleda file to my object bot. And since bot will basically be reused, the animation will be reused. We are going to have the main bot that is going to be controlled by the player, but we're also going to have robots that are controlled by the artificial intelligence that we're going to implement. So we do not want to have these curves that are only part of the object, that are only associated to the object. We want them to be reused by every robot that we will be creating. And for that, what we're going to do, we're going to force to convert the curve to tracks. Tracks are basically reusable assets. So like that, we do not have to duplicate any curve for any bone for each and every component. We're simply going to have one that will be then reused for each and every robot that we will be creating. So I'm going to toggle that on, and I am going to import my first animation. And if I go under the animation layout and under my timeline with my bot selected, I can see that I have now a first action that have been created. This action is called idle, so I'm going to rename it. And very important, I'm going to click here to build the action and resolve what is basically a scripting comment into real memory address that will drastically speed up the playback of my animation here. I am going to repeat that process for the other actions that I'm having in my Blender file here. So the next one is going to be forward. I am going to import them all, and after that, we're going to come back. The only thing that it's important is for each and every action, ensure that inside property, output properties, the range of the animation that you're exporting is correct. The first one was 1 to 64. This one will be from 1 to 21, and we're going to process each and every action the same way we did for the idle animation, and we'll be back in a second. So after repeating the process that we have done with idle, you should end up with idle animation, forward, backward, left, right, and death. So if we are getting closer to our robot, we are under the animation layout here. We are going to go under properties, application, and enable the script controller that is going to give us camera movement inside our viewport. Let's push here to increase the application time and get closer. If we're navigating, let's get closer to our robot here to test one of the animation that we have imported. Let's start with the idle animation. I'm going to stop that temporarily. I'm going to select the idle animation and I'm going to push spacebar to enter the play state. And I'm going to hit back the play button to increase the application time. We can see that our robot is now idling here. And you can see that basically the action repeat over and over and over. This is the default behavior when you're basically importing any type of action, which is great for idle, forward, backward, left, and right. That's what we want. We want this action to be looped over and over. The one that we do not want to loop over and over is the death. What we want to do is our guy, if I stop this, turn off the state of idle and go under death here and push spacebar to enable play, and I push the play button. I do not want our death animation to keep repeating like that. What we're going to want is our guy or our player or our AI bots are getting shot and they are only running the animation once and wait for the respawn. So what we're going to do, I'm going to stop this and stop the playback of this one here. And I am going to go in the curve area and push Control A to change the cycle mode to do not repeat the action. So Control A, everything is selected. I'm going to go under selection and then cycle mode, and I'm going to click this time hold. So what is going to happen if I start the playback again? We're going to have our death animation. Our guy's on the floor and then he stays on the floor forever. So then we can restart the proper animation when the robot get respawned. I am going to stop that. Now we have our robot actions that are basically imported. And now we are going to start coding the bot controller.